Hey everybody, my name is Eric. I work at Moderna. I'm a data scientist by profession. I manage two teams right now, data scientists who are in research and data scientists who are in the clinical development space. Outside of work, I'm also really excited about the new technologies that are showing up. And when it comes to things like agentic data science, I have been blown away by recent developments and I really wanted to share it. This thing that I'm going to be sharing has been all over my mind since I first saw it this year in March. If you haven't heard of Marimo notebooks, you got to check it out. If you've heard of Marimo notebooks, but you haven't heard yet of Marimo Pair, you got to check it out. And so that's what I'm going to be showing you. Now, in this demo, I'm going to be showing how we can use Marimo notebooks with Cursor to do exploratory data analysis using Marimo notebooks as the canvas on which we're doing our thinking, and Cursor as the agent that controls the canvas. What's been really cool about this is the ability for coding agents to reach directly into the kernel of a running Python notebook and manipulate it live. So if you're ready for it, let's get started. I'm going to flash up the code repository in which we're working, which is this guy, github.com/. It's got some installation and setup instructions. Make sure you have UV and NPM installed on your computer. Make sure you got Cursor downloaded, and then you also need to have a working internet connection. Make sure you create a work folder, and then install the Marimo Pair skill. That's the very first thing that you need to do. And if you are going to use Cursor in auto mode and the likes, I did a very lightweight benchmarking and a set of experiments to make sure that this works. I put some extra instructions in agents.md that will hopefully steer the coding agent in auto mode to do the right thing. But if you have a pro plan, you can actually use the premium models and the likes, and that'll be perfectly fine as well. Once we're done, we start by starting the Marimo notebook server. So we're going to do UVX Marimo edit sandbox no token, and I'm just going to do it with a demo.py over here. We can talk about what each element means here. Sandbox means sandbox mode, which means every notebook will carry its own dependencies. And no token makes it just easier for the coding agent to go in and makes it easier for the coding agent to access the Marimo runtime. I'm going to hit enter over here, and a Marimo notebook will be created, and it's going to be out here. I'm actually going to choose to work inside the embedded browser inside Cursor agent, just to show one way of working. So I can go to this guy and go here. There's an embedded browser. Awesome stuff. That works. All right. Since I'm on my laptop and not in presentation mode, I actually can zoom out a little bit and give myself a little bit more real estate. So the way that this works to establish a connection between the coding agent and the Marimo notebook is you start by saying, me connect to the Marimo runtime at, copy and paste this guy over here. And we'll let the coding agent do its thing. Give it a moment, and it should connect in a moment and do some dummy calculations. All right, there we see that. The server's running. It's going to connect. It's going to go in code mode. And this is really the mechanism by which it works. So for this demo, I'm going to work with a data set that I had worked with. And I'm going to give a little bit of background as to what that data set is all about. This is from a protein engineering campaign that I worked at when I was at Novartis. My wonderful colleagues out in Basel set up this protein engineering platform, and we did a machine-directed evolution of one enzyme, and we actually crystallized the structure, and we collected some data. The most important part is we collected some data. And just to give a little bit of background of what we're actually trying to accomplish here, what we did here is we're trying to take an enzyme and we're trying to introduce mutations into it to make it better. And that resulted in us collecting two types of data, conversion percentage and chiral selectivity. I'll go through that in a little bit more detail as we go about the analysis. So let's start with this. So I'm going to do copy relative path. And let's give some context. We're actually here to do an analysis of a protein engineering campaign on the IRED enzyme that came from Novartis. I would like you to open up the CSV files that are under the data folder. 002 corresponds to the conversion or the activity of the enzyme, and 003 corresponds to chiral selectivity. I would like you to open those two CSV files as polars data frames for me. Make sure we have appropriate variable names attached inside there. So we'll let that go. So it's going to spend a bit of time and do its thing. I'm going to close this file browser view. And in a moment, there should be some code showing up once it's finished doing its experimentation. Bingo, it happened right there. Now this notebook does not have polars installed in its ephemeral environment, and so Marimo actually will just auto install it for me. So it does that. Let's see what happens. So now I'm going to create the cell that loads both CSVs. Here's the first one. What's this one? This is the activity data frame. Awesome. I can see the point mutations over here on the left-hand side. And then I have the chiral selectivity. All right, just to maybe orient and level set some things, the way that it's represented in the mutation column is here's the wild type at a position, wild type A at position 111, mutant letter is C. All right, and then the mean conversion is the column that has the, oh, it did a bit of renaming as well. That's cool. All right. So the mean conversion is the value that we're mapping to the sequence itself. Okay, cool. So one of the things that we did before was this, what we call a deep mutational scan, where if you visualize on the x-axis position and y-axis possible mutant letters, 20 of them in total, you can try to test the effect of every single point mutation on the activity or the chiral selectivity. So one of the things we do is we'd actually go, okay, help me plot a scatter plot of just the single point mutations. They have no semicolons in the mutation column. And I want x equals a mean conversion and y equals R enantio selectivity. So we'll make that scatter plot and see what it's like. So it's going to install matplotlib. Well, I actually forgot to say, I want this as a plotly plot. So I don't want to use matplotlib. I want to use plotly in this particular case because we're in the browser. I want to introduce a little bit of interactivity, mouse over, etc. And again, we see that Marimo notebooks will auto-install the dependencies that you need if you are in sandbox mode. So let's see it work. There we go. It's going to detect that it needs pi-arrow auto-installs. Perfect. I'm going to close that. Rerun. It's got this. It needs pi-arrow dependency. Okay, let's try that again. There we go. Right there. Okay. I'm noticing not a very strong correlation. Add Markdown cell that interpolates the correlation and note my observation there. One of the things that I notice is like we get notebooks all the time that have no context. Really, no Markdown, no explanation, just code after code after code. Markdown cells, they're tedious to write. However, with coding agents, bingo. It's really easy to go in and actually go and write that notebook cell because you can tell a coding agent the idea of what you're trying to do. And it's going to help you elaborate. You just have to make sure it's correct, right? This is consistent with the common challenge. Yep, okay, cool. I like that. One thing I'm curious about actually is the ability to see the mean and maximum mutational effect. And I want to be able to toggle between the two of them so that it's a little bit easier. Help me create mean/max mutational effect for both chiral and chiral selectivity and activity. 2 drop-downs, 1 line chart. X equals position, Y equals value. So let's make that happen. Cool, so we got the mean and the property. And let's just see what happens going forward. Needs to avoid redefining fig. Great, I love that. Marimo notebooks don't allow you to redefine variable names, but if you're using the coding agent to control it, you don't have to think of the variable name. Just let the coding agent name it for you, right? So here we go, create the line chart via bash. Okay, Marimo line chart happening over there. And will it do that? Is it going to execute the line chart? There we go, right over there. So if I want the mean versus the max, and if I want property, there we go. We have fewer measurements for enantio selectivity, so that's really good. position 220 was really important. I remember that. And okay, amazing. Love it. So final thing that we're going to do. Final thing we're going to do is this. I really would like to be able to visualize the protein structure. So we have a PDB file inside data. I'd like you to create a 3D mold.js viewer, one that just visualizes the protein structure for me, and then we'll take it from there. So let's make that happen. Make the agent make that happen, sorry. We'll plan the next move. Okay, it's going to do its thing. It's going to write a little bit of stuff for me. Amazing. It's going to install anywidget. That's great. And it's going to make me an anywidget. Great, because this is going to allow me to visualize the protein structure directly. So it's got a mole viewer. It's going to take a 3D mold.js. That's great. Love that. And then it's going to run into some errors. Let's see what happens. I might actually need to refresh the page. Let me just see if that does the trick. And what if I restart the kernel? Okay, I'm getting an error. Getting an error here. Hit OK. Let's just see what it does. Okay, so it's going to do a bit of code fixing with anywidget. Oh, amazing. Look at that. Now I have the 3D protein structure over here. Yes, we do. I'm going to do it. Yes, we do. That's amazing. I know that there is the substrate that we need to view, and I would really like to be able to see the substrate in the enzyme binding pocket. It's a het atom. Ensure that you do the following. Chain A and B, it must be ribbon view. I do not want ball and stick, but for het atom only, I want ball and stick. So make sure that is the view that we get. Okay, great. Oh, we put in all the waters. Can you take out all the waters for me, please? Yeah, those little red dots on the side, those are all water. Okay, so while that happens, I'm going to plan out what we want next. So like we were able to visualize the mean and the max activity on linear position space, but really this is a 3D thing, right? And by the way, sorry, I got to take a little detour here. This enzyme, because I worked with it so much, it kind of looks like this, two hands together like that, right? But what's really cool is we have the position, when we crystallize it, we had the position, let me zoom out a little bit. We had the position of the active site right there. And that place where you see the balls and sticks, that's where the enzyme active site lives. Now, what if we could visualize in 3D space the activity or the value that we measured, right? So let's get the agent to make that happen. So what I would like now is the ability to visualize the mean or max activity or chirality, whichever we choose by the drop down, on the protein structure itself. So like I'd like the ribbon color to correspond to that value. And then also the ability to click on a residue and see a tooltip of the value that we're displaying over there. And also make it such that if I click on blank space, the tooltip goes away. Help me make that happen. One of the really powerful things about this is like with anywidget and reactive Marimo notebooks, you can create these custom viewers for exactly the problem that you're trying to solve. And the best part is this doesn't have to be a reusable component. It can be totally tailored to just the exact problem that you're trying to solve right there in the moment, which is the whole point of a notebook, right? Like you're not here to build reusable software necessarily. You are here to solve a problem through an interactive analysis, all right? And as we're going through this, I really wanted to reflect a little bit on what's going on, right? Like I am adopting a pair coding pattern with a coding agent where our artifacts are left on the canvas, which is the notebook itself. And we're adopting this like captain, vice captain, or captain driver kind of pattern where I'm the one setting the direction and going step by step, and the pair coding entity is the coding agent itself, and it's doing the implementation for me such that I can focus on what I'm seeing, the visuals that I need, the plots that I need to help with my comprehension, while the coding agent takes care of the nitty-gritty details of exactly what we're implementing, right? And as long as it's being implemented in a way that makes sense and is correct, then we're good. And of course, this being a demo, I'm not closely checking the code, but I would. And of course, because I know the data set like the back of my hand, I did the data analysis by hand itself. I know exactly what's going on inside here. So that gives me a little bit of an advantage. Oh, but look at that. Look at that. I have the ability now to visualize this. That's really cool. And am I able to click? Maybe I need to refresh. Let's restart the kernel and just double check. And I'll come down to here. Oh, I don't have the ability right now to click. Clicking on a residue doesn't really work, but that's okay. If I switch to max, the view resets and we have a different set of colors happening over here. Let's do this. The tooltip isn't really working right now. So can you try again? Because when I click on a residue, nothing shows up. All right, we'll make that happen. See what it does. So I'm continuing some of the reflections. We're really engaging in a way that is mostly, it is agentic, yes, because the coding agent is doing a lot of the work, but humans are in control. I'm actually doing a lot of the interpretation and thinking as the coding agent works. And one of the things I do remember interpreting was looking at the mutational map for mean activity. If I go back to mean activity over here, you'll notice we don't get a lot of good activity by mutating around the active site, right? However, oh, look at that. Now I can click and see exact residues. And if I come over here, alanine 156, I remember, was really important. And this is distal, by the way. It's distal to the enzyme active site. Here's another position, 216, 212, 221. Where is 220? 220 is this guy. Serine 220, also a really important residue. Alanine, tryptophan, right there, all right? So these were really important residues for us to be able to do the mutagenesis. And one of the really cool things that we had in the paper, if you're ever curious about it, is that we actually did the experiment that said if you mutate two residues that are distal to the active site, their effects are additive. They're not epistatic or nonlinear in that way. So I really hope that this demo showed for you the power of being able to use coding agents to control a Marimo notebook. And so one final thing I'm going to do pertains to documentation. As I'm going through the notebook, I want to note down some observations apart from the weak correlation. First off, the mutational effects, the mean and maximum mutational effects. I really would like that documented. I'd like to include in a Markdown cell the top 5 positions, rank for mutational effect by mean for activity, mean for chiral selectivity, and max for both of them as well. Put them in a Markdown table so that we have a little bit of summary of what's going on. And then below the protein structure viewer, I want you to insert another Markdown cell that describes what we're observing, which is most of the beneficial mutations are actually distal to the active site. They're not at the active site itself. So help me make those Markdown cells. And what I just did over there really pertains to this point about documentation in this interactive mode where, gosh, really no one writes Markdown cells because they're so tedious to write. But if I can just dictate exactly what I want, have the coding agent help me interpolate in a Markdown cell exactly what I need and actually use the variables from the notebook to interpolate into there, that is so powerful for reporting, for purposes and the like. So I'm so thrilled that the Marimo team put so much thought and effort. Trevor, who was the guy who really kickstarted this and showed this to me in March as a preview before it got released more generally in April, that was amazing. And so now I've got really high quality notebooks that I can share with colleagues, right? Because this then shows for them some really cool things. And it also shows position 220 was really important. Position 159 and 156 are also really important as well, right? That's the sort of thing. We can create these high quality notebooks through interactive data analysis with a coding agent as our pair programmer. And I really wanted to showcase that. I'm really excited for the possibilities of what's to come with agentic data science. And I think Marimo notebooks and coding, Marimo Pair, or more generally, this ability for a coding agent to reach into the kernel and interact with variables and read variables directly, I think that's going to be really powerful going into the future. My hope is this video was really helpful, gets your thoughts going, gives you ideas on how you can go back to your own orgs and advance the practice of data science. And I think this is really in line with that. So thank you for watching. Thank you for sticking around for a full, half an hour, 20 minutes that this final video after editing ends up being. Hope you got a lot of value from it. If I do another one, I'll see you in the next one.